Welcome back, ladies and gentlemen. It is time to get back to work. Well, decided to try and record the videos myself. We'll see if it works better or not. I'm going to try and get to 15 minutes or less, and I've already wasted 15 seconds, so we better get moving. Definitions we got to start with. A terminating decimal, something like 1/2. When I write it as a decimal, I get 0.5, so the numbers stop. So I suppose I should put the numbers first, but okay. The numbers stop when I do the division. A repeating decimal is going to be just the opposite, like 1/3. If you put that in, you get this 1.3333333 forever and ever. Numbers, guess what? Repeat forever and ever and ever. Okay, so in mathematics, we have a fun way of being lazy. We just put a little bar over it. It says, you know what? That goes on forever, and we're done with it. We got a little box here. We're going to start actually on the smallest box, because that's where we start when we're a little child. We start with what we call natural numbers. Think about when you first learned to count. You go 1, 2, 3, 4, and so on, forever and ever. Okay, the next thing we're going to add is whole numbers. And the only difference is we get to add 0. 0, 1, 2, 3, forever and ever and ever. Okay, what would be the next logical place? If you were thinking decimals and stuff. No, not quite, not there yet. Integers. So we're going to go -2. Oops, let's change that to a 3. 0, 1, 2, and 3. So you notice that 1 is a natural number, a whole number, and an integer. So we're no decimals, no fractions yet. Let's see here. The next thing we're going to have rational numbers. Rational numbers means can be represented by fraction. So, -2, you might say, how is that a fraction? Well, that's easy enough. -2/1. So notice that all the smaller boxes are inside of the bigger box, so we still have to find a way of doing those. We could also add 1/2, 1/3, 22/7. Sometimes we use that as a pi estimation. But anything that we can write as a fraction, okay? And that might be a repeating decimal, it might not be a repeating decimal. But if I can put it in a fraction form, good to go. Over here, we have irrational numbers. Means I can't write these things any other way. There's no way to put it as a fraction. So probably the most famous one is pi, and that's 3.141592665. And you notice that those decimal places just kind of go all over the place. There is no pattern. It goes on forever and just never starts repeating, just goes into all sorts of crazy stuff. There are other fun ones. Square root of 2, square root of 3. Remember that it means if I have a square, let's say in the area equals 4, what is the square root of that? Well, what would the side length of this square be? Well, this square would be a 2, so this is not irrational. Square root of 2 would actually come over here. It's just 2, right? Or square root of 4, excuse me. Because that is really 2, it's just written differently, so as a side note there. Let's see here. We can also do cubed roots. Same idea, but with cubes. You see that with a little 3 in there. And I do the same thing. There is no number. I'm looking for a number times a number times a number that equals 2. That's what this is saying. And there isn't a whole number. It's some goofy, weird decimal. If you punch it into your calculator, I don't know what it is off the top of my head, but it's something pretty small, like 1.2 something, something, something. Goes on forever and doesn't repeat. But those would be irrational numbers. So All right, let's move on here. We are going to change up something a little bit. We're going to split right here. These will be done in class. We will do those tomorrow as our warm-up together. So don't worry about anytime you see the word do's, that's how we're going to shorten our videos. We're going to save those for our warm-ups. So we got to take 5/8. We need to think of this as a division problem real quick. 5 goes inside, 8 goes outside. Got to add a decimal 0, otherwise I can't do anything. So now I go 50 divided by 8. Well, that's 6. 48, 2. Well, let's keep adding zeros here. Let's see what happens. That looks like 2. Gives me 16. Add another 0. And we finally are going to terminate here. So that one ended. Sometimes if I go add a couple of zeros, I can get it to terminate. Sometimes it won't. So this one here, decimal 6 to 5. Okay. Over here, we're going to have equals -1, and then I'll put a decimal place. Then I'm going to go solve that fraction part a second. So some of you are probably familiar with this one, and you won't have to write it all out, but bear with me. 20, there are 6 3's in there. There'd be 18. Okay, notice this 2 is the same as that 2, so when I drop down, now I have this 20 again, which is the same as that 20, which is why we get these repeating 6's forever and ever. There's another 2. If I add another 0, hopefully you see this is not beneficial in any way. I'm just going to keep adding zeros forever and ever, and I want to move on with my life. So I remember we said that up above. We express this mathematically as decimal 6 with a little bar over what repeats. So that's all we have to do there. Again, we're going to do these 2 questions over here tomorrow in class or whenever I see you next. So don't worry about those. We will talk about those later. On to the back side here. We're going to do a word problem here. What we are looking for is to create a fraction of, the bottom of a fraction is always the total possible. So that's going to be this number here, 530. Suppose I should read it. In a recent season, St. Louis first baseman Albert Pujols had 175 hits and 530 at-bats. To the nearest thousandths, find his batting average. So I need to go divide this out to several decimal places here. So I need that, and then I need to rewrite it like this. And this is going to be, at this point, most of you probably want to grab a calculator, but that's okay. We can do this, I think. So if I think of this as 500, there would be 3 of them in there. It would be 1590. I think the numbers end up working out pretty nicely here. I'll do a little regrouping there. 160, so that's going to be another 3 when I add a 0 here. And I get that 1590 right back. And I get just 10, 0, and to the nearest thousandths. I need to go tenths, hundredths. I need to go a couple more spots here. This is looking like just, well, I can't do anything, right, with 100. So 0, can't do anything, so I'm just going to, I don't show my subtracting 0. I'm just going to add another 0 here, and I can do that to 1. Now I can, this would be 530, and I'm going to stop here because I was asked to do nearest thousandths. That means I have to round to this place. The 1 tells me to leave it alone, so our answer is decimal 330. So 330 batting average is outstanding. Good season, outstanding season. Okay, again, we will do the do part tomorrow in class. Don't worry about that. Let's move on to write each decimal as a fraction. Okay, so we're just going to write that number on the top. And what place value? So we have the decimal, tenths, hundredths. And we can simplify that by dividing by 5. Anytime I see these 5s and 0s on the end, I'm going to divide by 5. Ooh, and now I'm done. So 9/20. All right. This one here is a little bit different because it's going to say this repeating 5. It's actually got a little trick to it as well. We're just going to copy down that 5 still. So the top number is still the same. In the bottom, what we're going to do is the place value minus 1 when we have these repeaters. I'll make a little note here. Place value minus 1. Let me write last place value minus 1. So this is in the tenths. Tenths minus 1 would be ninths. And if you grab the calculator and do 5 divided by 9, we get repeating 5s. And we're done. Look at that. 10 minutes. So see you in class.